last but not least, page 50, starting from page 55 of your student workbook, exam question 2. So this one here, it says a concrete square pyramid with a volume of 1.8 meters cubed sits on the flat top of a hill. The length of the square base of the pyramid is x meters. The height of the pyramid is 2.5. Find the value of x correct to 2 decimal places. So they're not wanting us to look for the volume. Instead, the volume's given to us and one of the parameters is missing. So seeing that this is it's given us volume and it's talking about a square-based pyramid, it would be pretty wise to pluck out the square-based pyramid formula. And in this case, it's going to be volume is equal to length times width times height divided by 3. Okay, now what do we know? We know that the length and width of the base is actually unknown, and length and width is the same. They're both x's. So length is x, width is x, and the height of the object is 2.5 meters. We also know the volume. It's been given to us. It says that it is 1.8 meters squared, and what we need to find is the unknown x's. So let's put everything that we have here into the formula for a pyramid. So 1.8 meters cubed is equivalent to x times 2.5 divided by 3. 1.8 meters cubed is equal to x squared times 2.5 over 3. And you can either use your solve function on your CAS calculator to solve for x, or you can do it manually step by step. So I'll do it manually because I don't have my CAS on me. So we're going to multiply both sides by 3. 1.8 times 3 equals x squared times 2.5. I'm going to divide both sides by 2.5, so that becomes 1.8 times 3 divided by 2.5 equals x squared. And to find x, well, x is going to be the square root of all that in there. 1.8 times 3 divided by 2.5. So let's find out what that's going to be. X is equal to, well, it says to 2 decimal places, so it's going to be 1.47 meters. That's that one there. Over to the next page. A few more exam questions before we finish up. Question 9, it says a conical water filter has a diameter of 60 and a depth of 24. It is filled to the top with water. So this cone up here is filled with water, and this water is going to empty into a cylindrical container, and this container happens to have a diameter of 40 centimeters. So all the water is allowed to flow in, and the question asks us, when the water filter is empty, so when all that water goes into the cylinder, the depth of the water of the cylindrical container will be which one of these? So how it's asking, when this empties into the container, into the cylinder, how high does it actually go when it fills up? Okay, so what we're going to do is find out the volume of this and how much it'll occupy in there. So let's just work out the volume of the cone for the moment. So volume of the cone, going to our formula sheet, V is equal to pi r squared h over 3. The r, or radius in this case, is 30 centimeters. Big H, or the height of the object, is 24 centimeters. And from there we can work out the volume. So pi times 30 squared times 24. It's pretty big. Oh, divided by 3. So volume is 22619.46711 centimeter cubed. That's the capacity. Now then, all this water is going to flow into it, and it's our job to work out the height of the cylinder, or the height of the water in the cylinder. So the volume of the cylinder is given by pi r squared h. We know that the radius of the cylinder is 20 centimeters. We don't know the height. We actually want to find the height because we want to find the height of the water that's actually going to fill it up. And we also know that the volume is going to be that one there. This is how much water that's going to fill into the cylinder. So we're going to replace what we know into the formula. So volume 22619.46711 is equal to pi times r squared, so 20 squared, times h, which is the thing that we want to know. Now, once again, you can use your CAS to solve it for you, or you can just do it manually, which I'm going to do now. So to work out what h is, I'm going to divide both sides by 20 squared pi. So that's going to be 22619.46711 over pi times 20 squared. That would give us our h. Type it into the calculator. You should come up with 18 as your answer. All right, 2 more to go. It says a cylinder of radius r and a height h has a volume v. The volume of a container with the radius 3r and 3h is going to be which of the following? Well, let's not just assume that just because we tripled the radius and we tripled the height that we're just going to triple the volume. That might not be the case. So let's have a look at the formula for a cylinder. Volume of cylinder is pi r squared h. Now it says that the radius is big R, so let's just make that a big R just because it wants to. So this actually sits very well. Okay. Now if you tripled the radius and you also tripled the height, what's going to happen? Well, volume is going to be pi, and you're going to triple R, and you're going to square it, and you're also going to triple height. And when you simplify it, you're going to get pi times 9r squared times 3h, and you simplify it further, you're going to get 27. 9 times 3 is 27 pi r squared h. So the volume, if you triple the radius and triple the height, you're technically going to also triple the volume. Not triple, sorry. It's going to be 27 times the volume there. As you can see, it's been proven right here. So the answer for this one is going to be D. Last one. The scale used on a map is 1 to 50,000. On this map, the distance of 4 kilometers would be represented by which of the following? Well, 4 kilometers on a map, 4 kilometers in real life is equivalent to 4,000 meters, which is equivalent to 400,000 centimeters. Now, if on the map 1 centimeter represents 50,000 centimeters, then 400,000 centimeters in real life is going to be represented by 400,000 divided by 50,000 to give us 8 centimeters on the map. So that would be C. Make sure you guys finish 17F, all the questions, so particularly the volume questions, which you haven't done as yet. And I will see you on Monday. Bye.